Hi there. In our lesson for today, we are going to explain Chapter 5, Lesson 3, Integration Methods. Part B, Integration by Substitution. Please do not forget to subscribe the page and ring the bell to get every new, and write your comment if you have any question. Push like button. And be careful that there is a link for exercise of this lesson down below at the description. My name is Tawfiq Umar, math teacher. Finding integration. Integration by substitution. If the function is consisting the product of two functions, one of them is the derivative of the other, use integration by substitution. If we have integration of f of gx, when we have the derivative of gx to dx is equal the original function f for gx plus c. Also, we can say if we have the integration of a bracket or a function with a power, we have the derivative of this function outside the bracket, we can take the derivative by adding 1 to the function power of function and dividing by a new power. Example number 2. Find the integration of 2x x squared plus 1 all squared dx. We are trying to solve this example in two ways. The first one, let u be equal x squared plus 1. And now try to find the du by taking the derivative of u respected to the dx. It is equal du over dx is equal to x because the derivative of x squared is 2x. And now try to find dx by multiply. It become 2 dx is equal to x dx. And dividing both sides by 2x, then dx is equal du over 2x. Because we have here 2x with the dx, so we don't need to find the value of x. And now substitute the value u and the value of dx. So the integration it be 2x, and in place of x squared plus 1 substitute u, it become u squared. Integration u squared du. It is easy to take the integration of this function. It become u with the power 3 dividing by 3 plus c. And now substitute x squared in place of u. It become x squared plus 1 all cubed over 3. And we can write this in another way by writing 1 over 3 x squared plus 1 cube plus c. Or we can solve this example in another way. Because we have the derivative of inside the bracket is 2x, so we have the derivative. To take the integration of this function, only add 1 to the power and divide it by a new power. So it become x squared plus 1 all to the power 2 plus 1 over 2 plus 1. And simplifying, it is equal 1 over 3 x squared plus 1 cube plus c. As you can see, is the same answer. Check it out, number 3. Find integration of 2x x squared minus 1. First of all, convert the square root to the power. It becomes 2x x squared minus 1 with the power 1 over 2 dx. And now, because the derivative of inside the bracket, it is 2x, so only add 1 to the power and divide it by a new power. So it becomes x squared plus minus 1 all to the power 1 over 2 plus 1 over 1 over 2 plus 1, and simplifying it becomes 2 over 3 x squared minus 1 with the power 3 over 2. And now to convert this power to the square root, only divide 3 by 2. Divide 3 by 2. It becomes 3 divided by 2. It is 1. And 1 times 2 is 2. By subtracting, it is 1. This is the result. The result is the power of outside the square root, outside of the square root. And the remaining is the power of inside the square root. As you can see, it is equal 2 over 3 x squared minus 1 times square root of x squared minus 1 plus c. Example number 4. Find integration from 0 to 1 for x squared plus 1 or cube dx. First of all, as you can see, the derivative of inside the bracket is 2x. We have x, but we are missing 2. We are missing 2. To complete this example or to solve this example, we must multiply and divide this x by 2. So we are multiplying x by 2 and dividing by 2, 1 over 2, or multiplying inside the integration by 2 and outside the integration by 1 over 2. And now we have the derivative of inside the bracket, so we can add 1 to 3 and divide it by write down 1 over 2 time add to the power 1, 3 plus 1 over 3 plus 1. And now simplifying this one, it becomes 1 time x squared plus 1 with the power 4 is x squared plus 1 with the power 4. And 2 times 4 is 8. And now substitute the first time 1, it becomes 1 squared plus 1 all to the power 4 over 8 minus, and now substituted 0, it's become 0 squared plus 1 all with the power 4 over 8. 1 squared plus 1 is 2 with the power 4 is 16. And 0 plus 1 is 1 with the power 4 is 1 over 8. Because the denominator is equal, so we can subtract the numerator. 16 minus 1 is 15 over 8. Check it out. 4. Find integration from 1 to 2 for x squared, square root of x cubed plus 1 dx. First of all, converting this square root to the power, it becomes integration from 1 to 2 x squared x cubed plus 1 with the power 1 over 2 dx. Because the derivative of inside the bracket is 3 x square, and we have the x square, but we are missing 3. So you must multiply inside the bracket the integration by 3 and outside by 3. So it becomes 3 1 over 3. And now you can take the integration by write down 1 over 3 and add with the to the power 1 over 2 1 and divide by a new power. It becomes 1 over 3 x cubed plus 1 with the power 3 over 2 over 3 over 2. When we are flipping it, it's become 2 over 3. And now simplifying this one, 1 times 2 is 2 and 3 times 3 is 9. So 1 over 3 times 2 over 3 is 2 over 9. And now first of all substituted 2 in place of x, it becomes 2 cubed plus 1 with the power 3 over 2 minus, and now substitute 1, it becomes 1 cubed plus 1 with the power 3 over 2. Simplifying, 2 cubed is 8, 8 plus 1 is 9 with the power 3 over 2 minus 1 cube is 1 plus 1 is 2, it becomes 2 with the power 3 over 2. And now taking or converting this to the square root, it becomes 2 over 9 times 9 with the power 3 over 2 is become the square root of 9 cube minus, and this one is become 2 over 9 times 2 with the power 3 over 2 is become square root of 2 to the power 3. And this one is become 9 square times 9. It become 9 square root of 9, and this one become 2 and square root of 2. Square root of 9 is 3, and this one is remain as it is, and simplifying it become 54 minus 4 square root of 2 over 9. Question number 1. Find the integration of x over square root of x squared plus 1. Let us go back for the derivative. Let us take the derivative of the fraction x squared plus 1. If we take the derivative of this fraction, it's equal. First of all, write 2 at the denominator times the square root of x squared plus 1, and take the derivative of inside the square root and write it at the numerator. It becomes 2x. As you can see, this fraction is coming from the derivative of this fraction. So to go back, we need to multiply the denominator and the numerator by the 2. So here 2 and here 2. And the integration of this one is equal square root of x squared plus 1 plus c. Question number 2. Find integration x square root of x minus 1. First of all, convert the square root to the power. It becomes x minus 1 with the power 1 over 2 dx. When we are taking the derivative of inside the bracket, it's 1. As you can see here that we have x more than this derivative. Because of that, we must use the substitution. Let inside this bracket be u. U is equal x minus 1. And now try to find dx and x. To find dx, take the derivative of this expression. It is du is equal dx. And now find x by taking minus 1 from right to left. Then u plus 1 is equal x. And now replace this value, it become. In place of x, we are replacing u plus 1. And in place of x minus 1, replacing u. And in place of dx, we replacing du. And now open this bracket. Multiplying u to the power 1 over 2 with the u, it become u with the power 3 over 2. And now multiplying u with 1, it become u with the power 1 over 2. Let us take the integration. The integration of u with the power 3 over 2 is u with the power 5 over 2 over 5 over 2 by adding 1 to the power. And the integration of u with the power 1 over 2 is u with the power 3 over 2 over 3 over 2 plus c. And now flip these two ones. 5 over 2 become 2 over 5 and 3 over 2 is become 2 over 3. So it is 2 over 5. And now converting u to the square root by dividing 5 by 2, it becomes 2. 2 times 2 is 4. Subtracting is 1. This one, the result be the power of u outside the square root. It is here. And this one is the power of u inside the square root. And now this 3 over 2 is become 2 over 3, and u with the power 3 over 2, when we convert it to the square root, it become u square root of u. And now replace in place of each u with the x minus 1. It's become 2 over 5. In place of u is x minus 1 square. And in place of this u is x minus 1. In place of this one, x minus 1. In place is this one, x minus 1 plus c. Question number 3. If gx is equal integration of cosine square x tangent x dx, which of the following is true? First of all, converting tangent x to the sine x over cosine x. And cancelling cosine with cosine, it remains integration of cosine x sine x. Here, we can solve this example in two ways. The first one, if we took that the function is cosine and the derivative is sine. As you know, the derivative of cosine is minus sine. So we need minus sine and minus outside the integration. So it becomes minus integration cosine minus sine x dx. And now we are taking the integration by adding 1 to the power of cosine and dividing by a new power, which is equal minus, this is the minus, and cosine square x over 2 plus c. And we can write it minus 1 over 2 cosine square x plus c. Or we can take that the sine is the function and cosine is a derivative. So the derivative of sine is cosine. It's only we need to add 1 to the power of sine and dividing by a new power. It's become sine square x over 2 plus c. It's equal 1 over 2 sine 2x plus c. As you can see, A and B are the two answers. So A and B are true, so we can choose D is a correct answer. Question number 4. Find the integration of 1 plus ln x cubed over x. First of all, write this function in this way. 1 plus ln of x all to the power 3 times 1 over x. And now, when we are taking the derivative of inside the bracket, the derivative of 0 is, the derivative of 1 is 0, and the derivative of ln is 1 over x. As you can see here, we have 1 over x, so only we can add 1 to the power and dividing by a new power. So it becomes 1 plus ln x to the power 4 over 4 plus c. Question number 5. Find integration x minus 2, x plus 2, x squared plus 4 dx. To take this integration, we must open these brackets. First of all, multiply x minus 2 by x plus 2, which is become x times x is x squared, minus times plus is minus, 2 times 2 is 4, because it is the difference between two squares. And this one is also is the difference between two squares, so it becomes x squared times x squared x to the power 4 minus times plus is minus 4 times 4 is 16 dx. And now you can take the integration by adding 1 to the power and dividing by a new power. So x to the power 4 become x to the power 5 over 5 minus 16x plus c. Question number 6. Find integration of 2x minus 1 square over 2 square root of x. If we took the integration of, if we take the derivative of inside the bracket, it is 2. We have square root is more than these two. So we must open this bracket and divide it by square root of x. It becomes the first one square, that means 2x square is 4x square. 2 times x, 4x. Minus it becomes plus, because minus 1 times minus 1 is plus 1. And now take, it becomes 1 over 2. Take this square root, convert it to the power and take it from denominator to the numerator and change the sign of the power. It becomes x to the power minus 1 over 2 times 4x squared minus 4x plus 1. And now multiply this with the inside the bracket. So it becomes integration of 2x with the power 3 over 2 minus 2x with the power 1 over 2 plus 1 over 2x with the power minus 1 over 2. And now take the integration. The integration of 2x to the power 3 over 2 is 2 times 2 over 5x with the power 5 over x minus the integration of 2x with the power 1 over 2 is 2 over 3x with the power 3 over 2, and the integration of this one is 1 over 2, 2 over 1 x with the power 1 over 2 plus c. Simplifying, it becomes 4 over 5 x squared square root of x minus 4x over 3x square root of x plus square root of x plus c. Question number 7. If gx is square root of e to the power x minus sine x plus 2 dx and g of 0 is minus 1, then gx is equal. First of all, we must take the derivative of e to the power x minus sine x plus 2. It becomes the integration of e to the power x is e to the power x minus the integration of sine is minus cosine, so it becomes plus cosine x. The integration of 2 is 2x plus c. Because we have g of x is equal minus 1, so substituted in place of all x's with 0 and in place of gx with minus 1. So it becomes e to the power 0 plus cosine 0 plus 2 times 0 plus c is equal minus 1. E to the power 0 is 1 and cosine 0 is 1 and 2 times 0 is 0 plus c. C is equal 1 plus 1 is 2. Taking from left to the right, it becomes minus 2 and minus 1 minus 2 is equal minus 3. So replace in place of c with the minus 3, gx is equal e to the power x cosine x co 2x in place of c write minus 3. So c is a correct answer. Question number 8. Use integration from 0 to the 2 x squared dx is equal 8 over 3 to deduce the value of each of the following defined integration. Be careful, x squared is an even function. A. Integration from minus 2 to 0 x squared dx. Because the function is even, so this one is equal the integration from 0 to 2 x squared dx, which is equal 8 over 3. B. The integration from minus 2 to the 2 x squared. Because x squared is an even function and 0 is the middle of minus 2, 2, so we can write this one 2 times 0 integration from 0 to 2 x squared dx. Then it is equal. This one is 8 over 3. 2 times s 8 is 16 over 3. C. Integration of from 0 to 2 for minus x squared dx. We can take minus from inside the integration to outside, so it becomes minus integration from 0 to 2 x squared dx. We have this one, so it becomes minus 8 over 3. D. The integration of from minus 2 to 0 3x squared dx. Because 3 is a constant, we can take it outside of the integration, so it becomes 3 integration from minus 2 to 0 x squared. And we found this one with the first one, it's 8 over 3. So this one is equal 3 times 8 over 3, cancelling 3 with 3 is become 8. Question number 9. If f of x bigger than 0 at interval from 0 to the 4, and the integration from 0 to the 4, f of x dx is equal 8, and integration from 2 to the 4 for fx dx is equal 5. Then integration from 0 to the 2, f of x dx is equal 4 minus 3, 30. As you know, we have interval from 0 to the 4, and the fx is in this interval is positive. When we are taking the integration from 0 to the 4, we can take the integration from 0 to the 2 plus the integration from 2 to the 4. And now the integration from 0 to the 4 is equal the integration from 0 to 2 plus integration from 2 to the 4. And now replace the value. The value of integration from 0 to the 4 for fx is 8, equal the value of integration from 0 to 2 f of x dx is required, so it remains, plus the integration from 2 to the 4 for fx dx is 5. And now by taking 5 from right to the left, it becomes integration from 0 to 2 f of x dx is equal 8 minus 5, which is equal 3. That means C is a correct answer. Here we reach the end of the lesson. Thank you for watching. With best wish for your success, and goodbye. Please do not forget that there is a link for exercise of listen down below at the description. Subscribe the page and write your comment if you have any question, and share it with your friends. Thank you for watching, and goodbye.